Good day everyone. Today is another class of physics. This class is for grade 12. In this class we will cover some worked examples in your textbook, and we will do some other questions which is unanswered in your text as well. So first we will start on page 61. Please try to follow me in that page. We will start with worked example number 3. So as we can see here in this figure, in this example said the beam shown in figure 19 is in equilibrium. So what we need here, the question is determine the force X. So as we can see here, this is the beam and this is the pivot. Here this is the center is here, and we have like 1, 2, 3 forces. We have 3 forces, and in different directions. Some of them clockwise and other is anti-clockwise. So we need to determine the force X, or find the value of X, the force X. So as we can see here, this is the pivot here. So we start here for the right section here, or this part. What we have here, we have 10 Newton force tending where to turn the beam anti or clockwise. This one is clockwise, and the X of this force is 1 meter from where? From the pivot. So we have the force 10 with distance 1 meter from where? From the center. On the other side here, the left one, we have first force is 20 Newton with distance equal to 0.5 meter, and we have another force here X with distance 8 meter. So from the right and the left one, or from clock and anti-clock moments, we can find the value of force X. The key solution of this example is what? The beam is in equilibrium, so is balanced. What do you mean by that? As we said before in last class, we said that the summation when the object is in equilibrium or balanced, we said the summation of clockwise moments is equal to what? The summation of anti-clockwise moments. The summation of clockwise moments is equal to anti-clockwise moments. So which one is clockwise and which one is anti-clockwise? The force here 10 is clockwise because it's acting this way, so it's moving with clockwise. This one 20 Newton also is clockwise. This one is moving this way, so it's what? Anti-clockwise. So unknown force X is tending to turn the beam where? Anti-clockwise. The other forces 10, 20 is what? Tending to turn the beam clockwise. So we start by calculating their what? Moments, and adding them together. So step number 1. So before we start, the key solution, or the solution of this example is what? The beam is in equilibrium, is balanced. So step 1, we will determine the clockwise moment, or moments, clockwise moments. So the summation of clockwise moments forces is equal to what? Is 10, this force, times the distance, 10 times 1 meter. 10 is force, for 10 Newton force, times 1 meter distance, plus which one? The other one here is 20 Newton times the distance from where? From the center here, times 0.5. 20 times 0.5. So why we take those, I mean those forces together, one from the left part and the other from the right part, because they are tending where? Clockwise. So 10 times 1 is 10, 20 times 0.5 is 10, so the total or the summation of clockwise forces is equal to what? 20 Newton meter. 20 Newton meter. Step 2, we would do the same but with what? Anti-clockwise. So moment of anti-clockwise is equal to what? We have only one force, which is x. X times what? Distance. So moment of anti-clockwise forces is equal to x times, this is x and this is times, don't be confused, x times 0.8. So because the beam is in equilibrium, so what? The beam must be balanced, and because it's in equilibrium and balanced, so the summation of anti-clockwise moments is equal to summation of anti-clockwise moment. So 20 is equal to what? This is the 20 from what? From step number 1, and this comes from step number 2. Anti-clockwise, clockwise. This part for clockwise and this part is for anti-clockwise. So 20 is equal x times 0.8. So it's easy to find x. X is equal to what? 20 over 0.8 is equal to what? 25 Newton. If you would like to check your result is correct or not, when you substitute the value of x here, it must be balanced the beam. If the beam is not balanced, so the solution or the number what you have got here is wrong. If you substitute this one here and then you find the anti-clockwise is not equal to clockwise moment, so the solution is wrong. So a force of 25 Newton here at distance of 8 meter from the pivot will keep the beam what? Still balanced and prevent it from rotating. So it keep it balanced or in equilibrium. So the key solution of this example is the beam is in equilibrium. Equilibrium means is balanced. So we will just follow the rules what we have said in the last presentation. Summation of clockwise moment is equal to summation of anti-clockwise moment. Clockwise moment is the forces acting or tending to turn the beam clockwise, and the anti-clockwise is the forces tending to turn the beam or anti-clockwise. Okay. Okay, we'll move to another example. So now is work with example number 4, I think on the same page. Work with example number 4, as you can see here, figure 20 here shows an internal structure of human arm holding an object. This is a human arm holding what? Object. Holding this object. So the biceps are muscles attached to one of the bones of the forearm. These muscles providing an upward force. So what we have here, as we can see in this figure, this is an internal structure of human arm. This human arm holding an object here. This is the object. I think of weight 50 Newton. Object of so there is a force here. It will be, this force is 15 or 50 Newton, sorry, it's 50 Newton with distance equal to 35 centimeter from where? The elbow. So the internal structure of a human arm holding an object, the biceps are muscles attached. This one here, this is a muscle called biceps. Biceps is a muscle attached the arm from here up to here. It's connecting between those two parts, attached to one of the bones here where of the forearm. So these muscles provide an upward force. This muscle providing what? Upward force. So there is a force here, force here. So an objective weight, as we said, 50 Newton, is held in the hand here. This 50 Newton with the forearm at right angles to upper arm. Use the principle of moments to determine the muscular force F. This one here, F, which acting this way, upward force. So we need to find the muscular force F provided by the biceps given the following data. So what we have here, we have weight of forearm is equal 15 Newton. Distance of biceps from the elbow is 40. Distance from this one, the force which we are going to determine, it is located at distance 4 centimeter from where? From the elbow. Distance of center of gravity from frame from elbow is 16 centimeter. 16 centimeter. It's somewhere here for example, and with distance equal to what? 16 from here up to here is what? 16 centimeter. Distance of object in the hand, this one from the hand, is equal to what? 35 centimeter. So all those data are given where? In the question. All of these values are given in the question. So now we will start to solve this question with first we need to simplify all information here and put it in a simple or simplified diagram. In this diagram we will show all the forces acting on the arm and the distance from where? Elbow. So this is the center here. So this is the elbow here. So what we have here, we will start from where? From this and move where? This way. And we will draw all the forces here. First force, we will move from here. We will find what? This force, which we are going to find. So this force, we will name it F. Unknown force, we need to determine it. Muscular force. F is unknown, we need to find it. With distance what? 4 centimeter. The distance from the elbow up to this force is what? 40 centimeter. Okay, now move. So keep moving here until we find what? Another force of 15 Newton, which is the weight of forearm. So the weight of this one, for example here, is equal to what? 15 with distance 4 centimeter. Distance of center of gravity from forearm from elbow is what? 16 centimeter. So this force is with distance 16 centimeter. Keep moving, we will find the final one. The force is this one. So this one tending this way, this one tending this way, this one is tending this way. So we have three forces. This is the first force, this is the second one, so and this the third one. The last force is what? Weight of object or object weight of 50 Newton. This is 50 Newton with distance 35 from elbow. So this is the simplified of this figure. We have an elbow. This is the elbow here. This is the elbow here. And this is the arm. This is the arm here. This is the arm. What we have here, we have three forces. This one, muscular force, F. This one acting where? This one is clockwise. This one as well is clockwise. This one is clockwise. So all the forces here are acting clockwise. So because there's a lot of information here in this question, it's best to draw a simplified diagram. Simplified diagram to show all the forces, all the distances, all relevant distances, and then we will start try to find the muscular force F. Okay. So now what we have here, first step or second step after we draw the simplified diagram, we need to determine what clockwise moments and determine the anti-clockwise moments. Sorry, this one is anti-clockwise, yes. This one is from here. Say here which forces are clockwise and which one is anti-clockwise. This one is where the distance from here up to here. So this one is moving where? Anti-clockwise. This one where the distance? This is the distance. So this one is moving where? Clockwise. This one is also clockwise. So the rules is what? The summation of a clockwise moment is equal to what? Summation of anti-clockwise moment. So we need to find this one and then find this one. So step 2 or step number 2, determine the clockwise moments. Summation of these moments of clockwise forces is equal to what? We will start with first force is 15 times the distance, 15 Newton with 16 centimeter. We will change it to meter, so it force 15 Newton times 0.16 meter. Plus another force here is what? 50 Newton times 0.35 meter. 0.35 meter. So the total value is 15 times 0.16 plus 50 times 0.3 is equal to 19.9 Newton meter. So this is what? Summation of clockwise. Now step number 3, we're going to determine what? Anti-clockwise moment. So the moment of anti-clockwise forces is equal to what? The force which we are looking for times what? The distance. Force times the distance. So it's equal to F times 0.04 watt meter. We change it from 4 centimeter to 0.04 meter. So because this one is unknown and since the arm is balanced, this is the key solution for this. According to the principle of moment we have, summation of clockwise moments is equal to what? Summation of anti-clockwise moments. So 19.9 is equal to 0.04 F. So F is equal to 19.9 over 0.04. It's equal to approximately 500 Newton. 500 Newton. So the biceps provide a force of 500 Newton, a force large enough to lift 500, for example, apples or something. So the force here is equal to what? 500 Newton to keep the arm what? Balanced in this situation. It's always trying to understand the question, trying to put all information or simplified diagram, try to determine which one is clockwise and which one is anti-clockwise. Make sure very carefully which one is clockwise and which one is anti-clockwise, and then just apply the rules here. Okay, now we will move to solve some unanswered question. Example number 5. It's not worked for I think this one is not worked. It's unanswered question in your textbook. So what have here in question, this question, we have a wheelbarrow is loaded as shown in figure 22. Section A, calculate the force that the gardener needs to exert to hold the wheelbarrow's legs off the ground. So there is a force here. There is a force here acting this way or tending this way. It comes from where gardener hands to take off the legs of the ground, the legs of the wheelbarrow from the ground, or moving it up. B, or section B, calculate the force exerted by the ground on the legs of wheelbarrow taken both together when the gardener is not holding the handles anymore. So we start with section A. As we can see here, we have what? This is the center here, so this is the pivot here. We have first force. We will move from here and up to here. So we are going to draw very simplified diagram to show all the forces with relative distances. So we will start for this point here, for example, here, and we have what? We will start moving where? Right, on the right side. Move. We will find what? 400, the weight of this, 400 Newton. It's tending this way, it's 400 Newton. Sorry for this because it's hard to write with the mouse. It's 400 Newton with what? 0.2 meter. So there is a force with distance. For section A, what we have as well. So now we are not talking about the force here. Calculate the force exerted by the ground. We're just looking for what? Section A. Calculate the force that the gardener needs to exert to hold the wheelbarrow's legs off the ground. So there is what? Another force where? Here. This force is where? Acting this way. With distance of what? 1.2 meters. So the distance from here up to here is 1.2 meter. And this one, for example, let us say F1 or F2 or any F1, for example. So for this one, we need to find what? This force. So what we have here, we have two moments, clockwise and anti-clockwise. This one is moving where? Clockwise. So we have like 400 Newton times the distance is 2 or 0.2 meter is equal to what? Is equal to F1, because this one is acting where? Anti-clockwise, is moving here, this way. The distance from this one and the force from the pivot here up to the distance. Sorry, the force. So F1 times what? F1 times 1.2 meter. So F is equal to what? F is equal to 400 times 0.2. 400 times 0.2 equal to 80 over what? 1.2. 1.2 meter. So 400 times this one and F is equal to time is the distance here 400 Newton times 0.2 is equal to what? 80 over 1.2 is equal to approximately exactly is equal to 6.666. So we will say it's approximately equal to what? 67 Newton. 67 Newton. So first one, we have two forces, 400 Newton down, and if there is a force here up, which is anti-clockwise, this one is clockwise with distance 0.2 meter, this one with distance of 1.2 meter. We just apply the formula that is anti-clockwise equal to clockwise forces, and then we will find the force F. Now we will move to section number B. Section number B. So section B, calculate the force exerted by the ground. So there is a force here at the ground here, where by the ground on the legs. There is a force here on the legs is acting this way. The legs of wheelbarrow taken both together, both legs, right and left one. When the gardener, it's very important, the gardener is not holding the handles, is not holding the handles. What does it mean, this one? This means that there is no force here. The force here is equal to what? 0. See, the gardener just left the handles of the wheelbarrow. So we will draw some simplified diagram for this one. We have the pivot here, and we move right. We have first force is what? This one, 400 Newton, which is equal to 400 Newton with distance of 0.2 meter. And then what we have here? We have this force here, force by the ground, or the force acting where? On the legs of this one. So this is the force here. Let us say, for example, F2 with distance of what? The distance from the pivot up to the force here is 0.5 meter. So apply the same formula. We will try to apply the same formula as in section A. We will say this one is clockwise, this one is anti-clockwise. So we have 400 Newton, 400 Newton times 0.2, this one, equal to F2 times 0.5. So F2 is equal to what? F2 is equal to this part divided on this. It's 400 times 0.2 is equal to 80 over 0.5 over 0.5, which is equal to 160 Newton. So F2, or the force here by the ground, is equal to 160. Okay, we will move to another example, example number 6. So in this question, as we can see here, this and traditional buyer or traditional buyer of scales uses sliding mass of 10 and 100 gram to achieve a balance. So it's a kind of scales, it's old one, using to move just try to move those masses here to get what? A balance. So a diagram of the arrangement is shown in figure 23 on page 62. The bar itself is supported with its center of gravity at the pivot. It's here, so the center of gravity is supported here. Section number A, calculate the value of mass M attached at X, attached at point X. So X is not a force, be careful, X is not a force, X is a point, distance from where? From this force or this mass here up to where? To pivot here. So X is not a force, it's a point, distance. So first we will find what? To calculate the value of what? Of M. So as we can see here, what we have here on the right section from pivot here, so if divided to right hand, we have two forces. This one 100 gram, another one is 10 gram, is a weight with distance of what? First one is 100 with distance 30 centimeter, second one is 10 gram with distance 45 centimeter. On the left side, what we have here, we have a mass here M, and now we need to find it with distance what? 20. So it's easy. We have two rules here to apply, the same rules in last questions. Clockwise moment is equal to what? Anti-clockwise moment, and the moment itself is what? Force times distance. Distance from where? From center of gravity or pivot. So we will find the summation of clockwise moment, and then we will find the anti-clockwise or summation of anti-clockwise moment. Say here this force is here, is acting this way, down, this one is down, so both of them is what? The distance is here. This one, where's the distance? The distance is here. So both of them is what? Clockwise. So what we have? We have, like, if we apply this, moment is force times distance, and summation of them, of those moments. We have 100, this first force, times what? Distance is what? 30 centimeter. 30 centimeter. Which is, for example, 303 meter. Is equal to what? Equal to what? 100 times this distance, sorry, plus what? 10 times what? This distance is 45 centimeter. 10 times 45 centimeter. It's 3 centimeter. So in this part we have two forces, both of them are clockwise, so we have 100 times 30 centimeter plus 10 times 40 centimeter, 45, sorry, centimeter. So 100 times 30 centimeter or 0.3 meter is equal to what? 30 plus 10 times this centimeter, change it to meter, change them to meter, or leave them in centimeter. It's same, because the moment it calculate, it could be Newton meter or Newton centimeter, same. 30 plus 10 times 0.45 is equal to 4.5, equal to what? M, this clockwise equal to what? Anti-clockwise. This one is moving this way, so this one is anti-clockwise because the distance is here. M times what? 20. M times 20. So M is equal to what? M is equal to 20 over 34.5 is equal to what? M is equal, sorry, no, it's wrong. M is equal to 34.5 over 20, which is equal to approximately 173 gram. So we need a mass of 173 gram to balance this scale. We need 173 gram to balance this scale with distance of what? 20 centimeter. So just apply the same rules here. Clockwise moment is equal to anti-clockwise moment. Those ones here are clockwise moments with distance, different distance, 30 centimeter, 40 centimeter, could be by meter or centimeter. And this one is anti-clockwise, so summation of a clockwise, which is 100 times 30 plus 10 times 45 centimeter or 4.45 meter, which is equal to 34.5 equal to M times 20. So M is equal to what? 173 grams, which makes the scale balanced. Section number B states one advantage of this method of measuring mass. What's the advantage of this? As we say here, by this method, weighting could be carried out with a limited selection of relatively small mass. So this is for question number 6. I think we still have one example. We will finish it. In this example, we have different forces here, as we can see in this figure 24, showing a beam with 4 forces. We have a beam here. This beam start from here. We have like 4 forces acting on it. For each force, calculate the moment of the force about point B. For each force, we need to calculate what? The moment. Moment is equal to what? Force times distance. Force times distance. B states whether each moment is clockwise or anti-clockwise. C states whether or not the moments of the forces are balanced. So we'll give you a key of solution and please try this question by yourself. It's very easy. It's exactly same the previous one. What we have here, we have this force, this is the pivot here. We have force number 1, F1 is 10 Newton, where is located at the center of the pivot. So the distance is equal to what? 0. Distance is 0. So F1, the moment of F1 is equal to what? The moment of this one is a force. Moment is a force times distance. M, for example, 1 is equal to F1 10 times what? Distance is 0. So the moment of it is what? 0. F1 is 0 Newton meter. F2 is what? It's a force 10 times 25 centimeter. 25 centimeters. So it's equal to what? M2 is equal to force times distance, which is what? 2.5 meter. 2.5 meter. And because the distance, say this is the force, and this is the distance. Always move where? To the center. Move to the center to determine which one is clockwise and which one are anti-clockwise. Start moving the force, keep moving the force towarding what? The center or the pivot. So this one is clockwise, this one is 0. The clockwise, the anti-clockwise. The second one, this is the question here. The second one is different. Yep. Or the third one. Fourth one is easy. Fourth one is what? Is a distance. If the moment of this, number 4 is force 5 times what? Distance. Distance is what? 25 plus 25, 50 plus 50 is what? 1 meter. 1 meter. So it equal to what? 5 Newton. 5 Newton times what meter is equal to what? As we can see here is 5 Newton, where this one is move here. Move to this one is anti-clockwise. Anti-clockwise. So what's about this? I will leave this one for you. What about this? This force is acting with angle of 30. Angle with 30. So try to solve to find the moment number 1, 2, 3. Please try to find M3. M is also what? Force times distance. Distance is here. And so what's the force here? You need to analyze it with as we discussed in the last presentation or last class. So there is a force with angle. Please try with it. It's very easy. So section C states whether or not the moments of the forces are balanced. Yes. At the final, when you find all the forces, you will find the moments are balanced. So this is all for today. Next class, inshallah, we will start another topic. So this is all for today. If you have any questions, please feel free to contact. Thanks for listening and good luck for review.